Well, here we go with extra credit opportunity number 3. First of all, multiplying these mixed numbers. So first I'm going to change this one to an improper fraction. So there's going to be 8 times 2 is 16, plus 1 is 17. So this one is 17 eighths. And then on this step, I don't have to write the parentheses. I could just write the dot for multiply, or I could write the parentheses if I want. But it's extra, you don't really have to do it. So with this one, change it. It's going to be 3 times 3 is 9, plus 1 is 10. So 10 thirds. And you could either multiply across the top and get 170, multiply across the bottom and get 24, and then reduce. Or you could do reducing now, which is what I'm going to do. This one could be divided by 2, and if you do that, it's going to leave 4. This one could be divided by 2, it's going to be 5. And then 4 will not divide into 16, 4 will not divide into 5, 3 will not divide into 17, and 3 will not divide into 5. That means it can't be reduced anymore. It also means that when I do the next step, it can't be reduced anymore. So this reducing right now saves some work later on. Okay, then multiply across the top. So that's 17 times 5. So this would be 35. And then this would be 5 with 3 more is 8. So it's 85 for the numerator. And on the bottom, it's just the 4 times 3 is 12. And then for most problems, you could actually stop right there, except the question had mixed numbers, so the answer should have mixed numbers. So I do need to change this into a mixed number. So 12 divided into 85. Well, let's see. 12 times 5, that would be 60, so that's not quite big enough. How about 12 times 6, this would be 72. Maybe I should try 12 times 7. So this would be 14 is 84. That's the best one. So actually it's going to be 7, and then 7 times 12 is 84. Subtract, the remainder is 1. So the final answer is that it's 7 and 1/12. Look at that, we're already 1/10 done. Next up, dividing these two fractions. So change this one to an improper fraction. 7 times 6 will be 42, plus 1 is 43. So it's 43 sixths. And right now, I'm not going to change this to multiplication because I still have to change this to an improper fraction before I can invert it. So this one, it would be 2 times 4 is 8, plus 1 more is 9, so it's 9 over 2. And now I can keep the first fraction the same, change it to multiplication, and then invert this one. And then I'm going to look for anything that I could reduce before I multiply, and I see that this could be divided by 2, which would leave a 1. This could be divided by 2, which would leave a 3. And 43, a 3 will not divide into it, a 9 will not divide into it, so it can't be reduced anymore. Next, multiply across the top is 43. Multiply across the bottom, this is going to be 27. And then, like I said in the last one, this needs to be made into a mixed number, only because the question was mixed numbers, so this should be a mixed number. So 27 divided into 43. Well, let me see, 27, if I tried a 2, this would be a 14, would be 54. No, that's too much. So it will only divide in one time. And then when you subtract, let's see, this would be 16. So the remainder is 16. So it's going to be 1, and the remainder of 16 out of 27. Next, for number 3, adding two fractions. And then you might think, well, we already did this last time, or even the time before. I guess it was just last time. Why are we doing this again? Well, the reason is when you look at these denominators and try to find out what number would be the least common denominator, it would actually be 350. And we could go ahead and do that. Multiply this by 35 on the top and the bottom, multiply this by 10 on the top and the bottom. But notice that this one could be reduced. So I'm going to do that reducing first. This could be divided by 7, it would go 1 time. This could be divided by 7, it would go 5 times. And then it's much easier to deal with these smaller fractions rather than the 7 over 35. So now instead of a common denominator of 350, the common denominator for these two is just going to be a 10. So this fraction multiplied the top and the bottom by 2. So it becomes 2/10. And remember, don't be 2/10. I love that one. I still need to make a t-shirt for that. Okay, anyway, to finish this problem, it is 2/10 and 1/10 is 3/10. And then that one, you can't reduce it, so it's done. Then on to number 4. So with this one, the least common denominator is going to be, well, it has to be at least as big as 121. So whatever the big number is for the denominator, the least common denominator is actually going to be that number or bigger. And then could this be changed to a 121? And if you know your 11Zs, 11 times 11 is 121, so it will work. Multiply this by 11 on the top and the bottom. So it's going to be over 121, and this one's going to be 5 over 121. But then I need to figure out this part. What's 20 times 11? So I could just do like I've been over here on the side, multiply it out. But this one, you could actually say, well, I know what 2 times 11 is. That's 22. And then it would just have an extra 0 on the end because of this. All right, now combine these together. So it's going to be 225 over 121. And then you always have to reduce fractions if possible. Well, with this, the only number that will divide into it is an 11, because I know this is 11 times 11. And would an 11 divide into this? Well, let's see, 11 times, so I know 11 times 11 is 121, and then this is like twice as big. So if I doubled this number, so if I took 121 and I doubled it, it would be 242. And then this is definitely not equal to 225. And if I were to subtract 11 from this, this would be 1, 3, 2 is 231. So 231 could be divided by 11. 242 could be divided by 11. Let's see, if I subtract another 11, this would be 0. So 220 could be, so these are numbers that can be divided by 11, but 225 does not show up. So that means this one is done. Now in the other problems, I had to change it to a mixed number, but this problem was given as an improper fraction as the question, so the answer can stay an improper fraction. Then 3 numbers. So I'm going to change this to an improper fraction, this to an improper fraction, and this to a fraction, which would be an improper fraction. So this one is going to be 30 plus 1, so it's 31 over 6. This would be 3 plus 1, so this one is 4/3. And then 4, I could rewrite as 4 over 1. So I changed each fraction or each number, but I didn't change the symbols in between. Now I do order of operations. And the order of operations say you have to do division before you do addition. So in a way, it's like it has parentheses around these two. So this first part, 31 over 6, and the plus sign stay there. And then for these two, I would change this to multiplication by inverting this. So it's going to be 4/3 gets multiplied with 1 over 4. And because of this multiplication sign, I'm going to have to do this multiplication first. Or in other words, it's as if there were parentheses still around this. And again, I'm going to do the idea of reducing first. These 4's can cancel each other out. So 4 divided by 4 is 1. So this will leave behind a 1/3. Okay, now to add these two fractions, we need a common denominator, which is going to be the 6. So this one needs to be multiplied by 2 on the top and the bottom. So it's going to be 31/6 plus 2/6. So that would be a total of 33/6. 6 will not divide into 33, so it can't be reduced. Then the question had mixed numbers, so the answer should have mixed numbers. So let's see, 6 divided into 33, it would go 5 times, so this is going to be 30 with a remainder of 3, so it is 5 3/6. But now once I've done this, the 3/6 could be reduced. You could divide by 3 and divide by 3. So when you divide by 3 on the top and the bottom, not on the 5 because the 5 is just the whole number 5, it's just this fraction we're reducing. So the final answer would be it's a 5 and then this would be 1/2. So the final answer would be 5.5. That was a close one. I almost ran out of space down here. Then for number 6. So because of the parentheses, I'll need to combine these two first of all. So get a common denominator. That's going to be a 6. So this I can multiply by 3 on the top and the bottom. This one I can multiply by 2 on the top and the bottom. So this one is going to be 3/6 minus 2/6. Okay, then keep the divided there, at least for now. And then for these two, the common denominator is 12. So in this first fraction, I could multiply by 2 on the top and the bottom. So then this one would say 2/12 minus 1/12. Okay, so we still need to simplify everything in the parentheses. So for this one, it's going to be 3/6 minus 2/6. That's going to be 1/6. At that point, I don't need the parentheses anymore because I've narrowed this down to be just one number. If you put the parentheses, it wouldn't be wrong. You just don't need them. It's still going to say divided. And then over here, 2/12 minus 1/12 is going to be 1/12. And then finally, change this to a multiplication problem by inverting the second fraction. And so you could reduce, or these numbers are small enough that you could just go ahead and multiply. On the top is 12, on the bottom it's 6, and then reduce that answer. So 12 divided by 6 is 2. We're already 60% done. So the reason I made up this problem is because if you look at this one and this one, it looks like there's not much of a difference. Yeah, that one has parentheses, but what's the difference? Well, this means take a 4 and multiply it by half. So in other words, take a 4, cut it in half, it actually equals 2. This is saying 4 and another half, so this is 4.5, and this is equal to just 2. So we would have 8, and then this one would be half of 4, so that's 2, and the negative sign still stays there. And then this one I'll change to an improper fraction. So this is going to be 8 plus 1 is 9 halves. Now that everything is narrowed down to addition and subtraction, just go from left to right. So left to right, combine these two. That's going to be 6. And then plus the 9 halves. And to add these two, I need to make this into a fraction first of all. Next, I need them to have the same denominator, so that's going to be a 2. So multiply this one, the top and the bottom, by 2. So the first fraction would be 12 halves plus 9 halves. Adding these together, it's 21 halves. Okay, so can it be reduced? A 2 divided into 21 will not go evenly. Once again, this has mixed number, so this should be mixed number. So a 2 into 21, that would go, well, first of all, 2 into 2 would be 1. And then that would be 0, carry this down. And then a 2 into 1, it would go 0 times. So multiplying this would be 0, subtract. That means that the remainder is 1. So it is 10, and 1 is the remainder out of 2. So 10 and a half. And then on to this fancy word problem that I made up. So this literally happens to me sometimes. I'm making a recipe and I have to double it or triple it or something like that. But since we're using mixed numbers, you have to make 2.5 batches. So there's 2.25 cups of sugar that's needed for every batch, and then we're going to make 2.5 batches. So we're going to more than double this. So if you double this, well, double this would be 4, double this would be 2 fourths. So the answer has to be bigger than 4.5. So it's got to be 5.5 is just my estimate. But if I get an answer like 1/3, I know that that's wrong. It has to be like 5 or 5.5 cups of sugar. Maybe even 6, I don't know. But 5, 6, somewhere around there. Well, in order to find out, we need to multiply. So it's going to be 2.25 cups of sugar for every batch. And then do that 2.5 times. So multiply. And then change this to an improper fraction. So 4 times 2 is 8 plus 1. So this one is 9/4. This one would be 4 plus 1 is 5. So 5 halves. And when you do the reducing, it would have to be, does a 4 divide into a 5? No. Does a 4 divide into a 9? No. Does a 2 divide in? So it has to go the top and the bottom. The top and the bottom is what we're checking. But it doesn't work in any case. So just multiply across the top would be 45. Multiply on the bottom would be an 8. And if I were making a recipe and you told me, yeah, go ahead and use 45/8 cups of sugar, I would then have to get a pencil and paper and then divide, or calculator, and divide 8 into 45, because I'm not going to sit there with 1/8 of a cup of sugar and do that 45 times. So I need to make this a mixed number is my point. So an 8 divided into 45. Let's see. If I put 5, I think that would work. 5 times 8 would be 40. So that means the remainder is 5. So yeah, that's it. So it's going to be 5 and 5/8. So it would be 5 and 5/8 cups of sugar. And then we're almost done. 2 questions that are similar, and that is, which fraction is bigger? So just which one's bigger? By looking at them, I honestly don't know. There's a couple of ways to do this. By the time we finish this class, I think we'll have probably 4 different ways that we can do this. But since we're on the section with mixed numbers, that's what we're going to use. So take this one and change it into a mixed number. So 9 divided into 17. Well, 2 times 9 would be 18, which is too big. So it's only going to be 1 time. And then multiply to get a 9. Subtract. The remainder is 8. So that means that it's 1 and 8/9. So the remainder was 8, so it's 8/9. Sorry, that was a little bit sloppy. So this one is 1 and 8/9. Okay. What about the other one? So the other one, 70 divided into 127. Well, if I tried to put a 2 here, 2 times this would be 140, which is too big, so it's only going to be 1 time. Multiply this would be 70, so subtract here is 7, 12 minus 7 is 5, so then it is 1 and 57 70ths. So this one is 1 and 57 70ths. Well, that makes it just a little bit easier, but not by a lot. So this is 1 and some change. This one is 1 and some change. So the 1 parts, when you're comparing them, the 1 doesn't really matter. Those are the same. So really we need to know 8/9. How does it compare to 57 70ths? Which one is bigger? Well, here's one way you could do it that we actually haven't covered in class yet. So what you do is right here is supposed to be the symbol less than or bigger than. But I don't know what it is right now, so I'm going to just put an open circle saying I'll put the answer right there in a second. Then what you do is cross multiply. Multiply this over to here. So it would be the 8 stays there. Cross multiply this direction, so it's going to be times 70. Then take the 9 and multiply it onto this side. 9 times 57. And then the open circle would still go right here. Which is bigger? So 70 times 8 would be 560. 57 times 9, this would be 63. This would be 45 and 6 is 51. So this side is 513 and this side is 560. So what goes in this open circle right here is actually that 560 is bigger. That means this is bigger, that means this is bigger, that means this is bigger, that means this is bigger. Woo, that was challenging. And then for number 10, the same thing, but what about with negatives? Dun, dun, dun. Well, here's a different way you could do it. A different way, so you could do this problem just like I did the last problem. Here's a completely different way. The different way is you get a common denominator. So for these two, the denominator would be 8. The common denominator would be 8. So multiply this by 2 on the top and the bottom. So this one stays the same, negative 121 over 8. Or is it this one? And 51 times 2 would be 102 over 8. So now that the denominators are the same, I don't really have to pay attention to them. I just have to see which is bigger. Is it negative 121 or is it negative 102? Well, if we're talking about positive numbers, this would be the winner. If we're talking about positive, then 121 would be the winner. That would be bigger. When it's negative, it's actually the opposite. Because if you look at a number line, 0 would be right here. You'd be going along, eventually you get to negative 90, eventually you get to negative 100, negative 110, and negative 120. So negative 121 would actually be right here. And the negative 102 would be right here. So the question was, which one is bigger? This is the one that's bigger. And like I said, since the 8s are the same, you don't have to compare those. This one is the one that's bigger.